Hello everyone, so my name is Allison and on behalf of Team 19, I will be presenting our portal frame warehouse design for CIVL201. So this presentation outlines our design processes from our parameter selection, structural modeling to wind loading and connection verification as well. We've used Revit and SpaceGas, and of course it's all in accordance with AS4100 and also AS NZS 1170.2. So this is our team. We've got Tyler, myself, Ron, and also Tom. So for design parameters, the client requested a 40-meter building length with a span of 18 meters, as you can see in our design here. They've also requested at least an 8x5 mezzanine floor, but we've adopted a 9x17 meter mezzanine floor just because we have a long portal frame. And we've got an eave height of 7 meters and also a rafter load of 14 kilonewtons per meter, which represents the combined roof, dead load, and live load and service loads as well. So we've got a roof pitch of 6 degrees for good drainage and also the solar panels that we were going to install later on. So this is the interior of our portal frame warehouse. So in terms of our structural system overview, these are the members that we have chosen for the loads that it will carry. For the frame spacing, as you can see, we have a 5.7 meter spacing, and we've got the 400 mil reinforced concrete slab. So for wall cladding, we've used the Lysite spandex, which is a 24 mil thick cladding, and also a clip block classic for the roof sheeting, which is 40 mil thick. So the spandex profile for the wall cladding, it has deep ribs that resist wind suction and reduce the number of guts required, which is more economical. As you can see with our design as well, we've used the Manor Red as a wall finish. It just complements the Wollongong's coastal industrial palettes, but also at the same time, it has light reflective coating, which lowers heat absorption and also improves thermal comfort and also energy efficiency. So some questions that we have received from our clients. So why we have adopted a steel portal frame design, because firstly, as you can see, there's not much interior columns, so it has an unobstructed workspace. So it's a clear span design, but also at the same time, it's very cost efficient because a lot of the steel members is prefabricated. So it's also very easy to build and also very time efficient. You can see we've got 10 windows. It's the minimum requirement from our client. So this windows is positioned for natural lighting and also cross ventilation, and we've got the roller door at the very front for vehicle entry and also the personal door at the side there. With the 6-degree roof pitch, unfortunately it just increased the wind uplift, but we have safely handled that in our wind analysis. Just a quick interior walkthrough of our portal frame. So that's our mezzanine floor, and also we've got the windows and the doors at the side and the roller door there. Okay, so just talking about the wind analysis. So our site in Wollongong, it's located in region A2. So with region A2, it is classified as a normal wind speed, which has 45 meter per second design wind speed, which we use for the design. As you can see here, we've got 4 load cases for uplift and lateral wind pressure, roof suction, and also partial internal pressure. And as you can see here, it has smooth curves, which from the columns to rafters, it is equal load sharing. So for structural connections, we've used SpaceGas to determine the plates and also the bolts that we're going to use. So that's for our base plate. This is for column to rafter connection and also our apex connection. So as you can see here, our chosen members have higher capacity than the maximum bending moment, shear force, and the deflection as well. So it all passes AS4100. And also at the same time for our connections, the base, knee, and apex connection, it's all less than 1.0. So it passes AS1170.2. So technically that concludes the end of the report. If you have any questions, just let me know. And also thank you for your time.